Hey everybody, Brian here from quantlabs.net. Just wanted to go over with you the call-put parity model done in Simulink here, and what it can do with all these little knobs and gauges and a little lamp for options trading. I'm not going to really teach you about put-call parity, but I'll try to do my best to explain it. Okay, so right now what you're looking at is a Simulink model, which is part of MATLAB. And essentially what we've got here is a very high level model diagram. We've got 4 inputs going into a state flow chart. I'll break that out in a minute. And on the output of that state flow chart, it will have 2 flags. Are you in the money or at the money, or you got an arbitrage? And all of these can be reflected in real time based upon the data I provide. In this case, okay, so again, let me just explain something on the Simulink models. We have our inflow, which is our data going into our chart, or basically our Simulink model. I'm just using this state flow as the entire Simulink model. And then the resulting part, which is the outflow. Okay, so we have 2 outflow parts, which are really, are we in the money? And do we have an arbitrage opportunity from the put-call parity formula? So everything's all simplified. I just wanted to showcase what this can do. As you can see, these are all blocks. Each one of these is a block. So this is what we call a constant block. This one here is a chart. Like I said, I'll explain that in a minute. And then this one is a sink, which is really just an output of a variable in the Simulink model. All right, so let's get into the state flow. So in the state flow chart here, we have 3 parts. Now, what you do need to realize is not exactly perfect, but it's just really more for demonstration purposes on the capabilities of state flow and Simulink and how you can apply it to your trading and simplify your, we'll call it rapid trading idea development. It didn't take too long from the ground up. Once you understand the concepts and the behavior of how state flow and Simulink work to do this. All right, so we have our state flow chart. What we have here is, as you can tell, state flow is about states. So we have 2 states here, one called in the money, out of the money. Right here we have a transition. This transition here, this little guy right here, is the default transition. Basically, once the data is fed into it, this is the starting point of the state flow, or of the state flow chart. So the first thing gets executed. Also, what it will do on execution, it will execute the function here, which is a MATLAB function called call-put parity. That's the formula. So here's the function, and essentially what we're doing is we have 4 arguments: call price, put premium, strike price, and future price. That all comes back to, quite simply, all our inflow data. So we got put premium, call premium, strike, and future price. Okay, pretty simple, right? So knowing that, all we're really doing is feeding those 4 arguments into this function, and all we're doing is we have a parity formula, which is essentially, we have on the left-hand side, LHS, call premium minus the put premium, and the right-hand side, or RHS, the future price minus the strike. So those are the differences. So essentially what the call-put parity says, if the left-hand side is equal to the right-hand side, we have either an arbitrage opportunity or we don't. Now, if they don't equal, we have an arbitrage opportunity. So if you go back to your C days, which most people have done, you have a flag. So we're setting that to true. If it's not, if the parity does hold, then we set the arbitrage to 0 or false. So these are flags, modes, whatever you want to call them. I just put this little piece of code here, which is commented out. Which the comment is using the percent sign. So I'm going to play with this in a minute, part of the simulation, so you can see what happens. Okay, so that's essentially the whole model in Simulink. Pretty simple. So if we go to our actual model, as I said, we have these knobs, we have some output diagrams. I showed this before in a basis model. So here is our browser for all the different blocks. As I said, each one of these is a separate block. So we have a knob block, set of knob blocks down here. We have, this is called a lamp block, which can be found under here under dashboard. Dashboard. So we got this little guy, and then we have the arbitrage, which is using the linear gauge. Okay, so let me just walk you through each one. Here, if you look at a signal, which points back to the call premium value, which is this call constant here, that is associated with this call premium block, okay, constant block. And when you run the simulation, you can set the value of each of your knob that will affect the call premium. So this one will be for the put premium, future price to this, strike price to that, okay? Pretty simple stuff. And of course we can set our minimum and maximum in each block. Okay, so in this case all I did was, this is just for testing and demonstration purposes. I mean, there's going to be never negative call premium, we know that, but it's just for demonstration purposes. But we can set the user input, and then these, what they call viewers, are reflected on how we adjust our knob. Next up we have our at the money. So essentially we put that associated to one of these signals here, and that will be either, as you can see here, with 0, 1, it's green or red. Pretty simple. This one will change as well, which is our gauge. So we have our minimum, this is our arbitrage. So remember in the code, on the arbitrage, here, this is what we want. Just cancel that. So in the arbitrage return here, we set it to one of 3 conditions: 0, 1, or -1. But I'll show you the -1 once we get it tested. All right. So with the browser, those are the only really ranges that we can work with: a -1 minimum and a maximum of 1. This is really useful for when you are going to be down the road working with options. These gauges are very important when you start playing with your data, like high-speed data, and you can actually see the gauges reflect on whatever you set at, and that can include, for options trading, could include your Greeks, like your delta, your vega, gamma, and all that, or whatever. And of course we have our sync as well in the output. Okay, so here is where we can fire this up. A couple of other important diagram panels that we work with is we got the library browser, which I showed you. We've got pretty well the heart and soul of the entire model is using this model explorer, because I'll show you this in a minute, but I know you're probably wanting to see this thing run. And then of course, last panel is the viewer, which is really, will show any problems when we're running the simulation. Now, as you build out the Simulink model, you're going to run into all kinds of problems as you create the model and build the different components. All your errors get reported in this Diagnostic Viewer. And where do you see all this stuff? If you come under here, under View, you can see Model Explorer. You'll get your Diagnostic Viewer and any other viewers or anything else you need. But those are the two that I've been generally mainly using. So let's fire up this puppy. Oh, one last thing I better forget. If you've seen one of my simulations in the past, in here you will find a configuration just trying to remember where I've nope. Okay. Essentially, what I want to show you is the setting to enable you to run your simulation forever, like to run it infinitely, in an infinite way. So yeah, this is it here, right here. So you can set the stop time to run once, and that's it. Or in my case, we want it to run forever, which is infinitely, right? That's such a word. Okay, so you can see here it's running now forever, basically. So as I said, we can set our knobs, and they get reflected in these viewers, as they call them. That's very cool. Now, this is the cool part of Stateflow. If you had real live data, you'd be able to see with this blue animation, seeing what's happening here. So essentially, if we had a real time data flow, you'd see all these different elements of the Simulink chart be highlighted in the blue, but it's just constantly being set at the money for whatever reason. So that's a very powerful feature in debugging and seeing your system run live. Okay, so you can see here we've got our results. We have a so-called arbitrage opportunity. It says so in the arbitrage because little gauges is set at 1. So let me just stop this. So now let's go into our code of where this function resides. This is what I'm referring to right here, is this MATLAB function. So that's, remember, that's run on the default transition when the Stateflow is executed, when it receives all the inflow data. This is the first thing it's run. So we're going to modify this function. So what I'm going to do is I'm going to comment all this stuff out. Okay, just comment it. But I'm going to uncomment this. Okay, so what will happen is when we run it, essentially this arbitrage opportunity will just go back to -1. Okay, so let's run it. There you go. The gauge is now at 1. So if you think that's smoke and mirrors, let me just show you one little thing. I can also set this to 0. But you can see the power of it visually. You don't need to have a lot of coding skills to be able to play with Simulink models that you build out. Let me just run this. Let me get our Simulink model. So you can see that the gauge now is at 0 because that's what we've hard coded it to. And whoop-de-doo, right? So let me just uncomment this code again. Okay, that's cool. That is awesome, I guess. All right, so you see here we have this, what they call a directive called Cogen. It's a directive to tell MATLAB when you try to cogenerate that this function should be part of that cogeneration process and to generate code for it, be it C or C++. So we need that in all functions. All right, so let's check out the real power, the real reason why. So you're probably thinking all this is a fun toy to play with. You can get this all in MATLAB Home Edition for about 100, 200, 250 bucks for each toolbox. But essentially you just want a Simulink toolbox for 50 bucks if you go with the Home Edition. Now, the power of Simulink comes through this. And I've showed this before many times actually. But if you come under here in the code, you can actually, believe it or not, let me just show you here. You can set targets, you can set your compiler. Here I've got it to work with my Visual C++ compiler. I can set the language, C or C++. So what I'm going to do is, remember I told you about that viewer? So here's the viewer, all the simulation runs that we ran in the past little bit. But in this case, I'm just going to clear out all of this historical stuff. So what I'm going to do is let me just show you the comments here. Here you can set comments, and personally I like to have comments. I understand them. But this is what gets generated as part of the cogeneration process. So you can see eliminate blocks, source code is comments. So essentially what you'll get is you'll get this guy thrown into the final C or C++ code as part of a comment. So you can actually trace it back to the logic in your C once it's co-generated. It's very powerful, very helpful. Okay, so also we can comment or include Simulink or stateflow comments as well. Very cool. And yeah, that really helps out. So I'm gonna click here the cogeneration process, and let's get to it. So all I could generate. I've shown this before. You can generate a Visual C++ project that will automatically get loaded up in your Visual Visual Studio, and it can create a exe file right from it before I've confirmed that works. But in this case, let's just do generate code. Okay, we just got to make sure. So here we've got this project. Okay, that's not much. We don't need that. Let me just clear this out. Okay, all right. Let's get that cogeneration process happening. Okay, it's going to generate our code. Yeah, so we're going to remove that folder, apply, off she goes. So what it's doing right now, it's going to start generating code, C++ code. In the part, it did issue some warnings. Generally, you don't want warnings, but in this case, I'm not going to worry about it too much. So there is our report for the code, and you can see that the build process has been completed. This is very powerful because here you can see the code that gets generated. Very powerful, and here you got your input settings on those knobs, which is really these guys right here. See 25.6, 51.2. So we can have references back to the premium price and all that. This is automatically generated. This is one of the only ones that I can honestly tell you that actually does the job that it's supposed to do. Here's the state flow. Remember that state, if it's out of the money, meaning if the value is greater, the strike price value is greater than the future price value. So it does work. So here's some of the other state flow stuff that we've state flow in the money state I showed you earlier. It's very powerful. I'm just looking for our function, the MATLAB function. Let me just see if we can find it. Here's the header. Now here's some of the blocks. So, but you can see it's all been the comments are generated automatically, which is great because it helps you trace it back for debugging purposes. And it is efficient code, as far as I know. That's what MathWorks, the vendor behind MATLAB, promises. And I believe it because the Coder product is not a cheap product. It's not a toy, as I said. This is real stuff. Anyways, I know our block should be in there somewhere. or sorry, our MATLAB M function should be in there somewhere. I've seen it before. Just trying to find it, but it is included in there. So you should be able to build this code no problem within your compiler, because you have to embed it within your MATLAB itself. All right, so let me show you this folder here. Okay, so this is the folder that contains, this is the Simulink, that's SLX, is the Simulink model, which is essentially this guy and all the stuff that goes with it, including the state flow. All right. Not only that, we have two. Okay, so this is the latest code I just generated. But for those that really can't afford MATLAB or MATLAB Simulink or even the Simulink coder, I will give this code, because I know where everyone's going to go. Where do I get the code? How do I get it? Well, that's pretty easy. If you join my Quant Leap membership, that's where that code resides. Okay, all this code, the Simulink model, everything. This is the first. This is a good reason why I'm going to be moving off of Windows for just these lags of Windows. Don't ask me why, but it's a very painful process. But if you come to my site, you come under Elite. I've created this new benefits page. Just explains what the benefits of my membership are, and you can just join right here. So this model will be part of that. When you join, you'll be able to download and play to your heart's content. Of course, including the C and C++ code here. There's a C folder, and then there's a C++ folder. What's generated from the Simulink coder. Okay, so hopefully you see the big benefit of using something like Simulink. So essentially, I know you can input all your data through your inflow, control it through these knobs. Kind of cool if you ask me, but what to do. So just from the simulation point of view, it's pretty powerful. And then you get obviously the output, maybe a flag or whatever. And of course you have your state flow chart, which is pretty powerful in itself. You can include your functions, your MATLAB functions, and then of course I haven't talked about MutePad as well, which you can use, which is a glorified editor for scientific notation if you have more sophisticated algorithms or formulas or equations. Okay, so this is why I'm choosing this methodology or workflow. If you come under my YouTube channel, let me just get that right. If you come under here, I have my playlist. If you come under my best workflow to HFT, you'll get all the videos related around this demo. But now I've been enhancing it. Not only that, let's say I also include another video of a demo using basis, the future basis, or basis for futures between the cash and a future price. So what do I mean by that? I've got here, let me just see here, okay, just give me a second here. Yeah, right here, I've got another model I'll also throw up on my my membership as well. It's similar. I've got a whole video around this. It's the same concept. We've got here an inflow of a cash price and a future price. In this case, we've just got the basic basis algorithm or equation between the difference between future cash price and the future price. And then also I've got a little dinky truth table attempt and a scope. But if you run this, let's see if I can put that on. Let's just see what would happen here. So hopefully I was okay. So it's running now. So if I put the flash, but you can see it running. This should get updated for whatever reason, but I'm also going to include this model as well. So we're well on our way in understanding how to use Simulink state flow, and just for our simulation purposes, very cool way to develop trading ideas. Nothing like it out of my 5+ years that I've seen. And the other cool part is that within one model, so let's say in a state flow, let's say this basis is one Simulink model. Okay, no problem. But something that I haven't tried out is in the Simulink state flow, you can include obviously MATLAB functions, but somewhere in there you can also add a Simulink function, right? So in my case, I could add the basis Simulink if I wanted, right? But you can build, to your heart's content, a hierarchy of Simulink models, of MATLAB functions. Another cool thing in here, if you go under the viewer, where's my model viewer? If you come under the model viewer, this is very cool too, is view model viewer. Okay. This is what I was wanting to show you. I'm kind of glad I'm actually showing. This is the heart and soul of the Simulink models. Okay. Now, this can get really confusing. There can be name collisions between a Simulink and a state flow. So each set of variables have to be unique. Okay. And that's part of the uniqueness of Simulink. But in this case, what was I wanting to show you? Oh, right. So here's the state flow here. But here, this is now the state flow chart. Put call parity. This guy put call parity. Put call parity. So under the Model Explorer, here you can set your action language from MATLAB or C. That's very cool. Not only that, but in the Simulink or actual model itself, you can set callbacks that will interface as well on initialization, when you start, if you do a pause, if you do a stop or whatever. That set of code will get run, all compatible with C. Very powerful. Again, you can co-generate this. Now, if you don't think that stops there, we showed you the C++ and the C cogeneration. But check this out. Now, let's say, actually, I got to stop this. Let's just say I want to do HDL. Still fairly new to just go into the other model here. We'll go into this one. Okay, so let's say you want to co-generate, but now if you want to go high frequency trading, this is the place where you can go. Because guess what? I've shown this before. You now have the ability to take the same model that you can co-generate to C or C++, and you can also code to a HDL, hardware description language, for FPGA. Burn it around the board using VHDL or Verilog, which are the proprietary languages for both mainstream boards of Altera or Xilinx. Now, I've never done that before. I'm not going to get into it, but that capability does exist in Simulink. Very powerful, and opens up another world so that you can burn your model that you build in your Simulink, and you can burn it right onto a board and have it deployable into an HFT box with your FPGA boards. It's another huge advantage of why I use Simulink. Okay, so we've got here this other model called Parity. Okay, we've got that model. I'm going to put up on my Quant Elite membership with the C code. On top of that, I'll also include the basis one as well. Hopefully, this is enough for you to really jumpstart your trading idea and to deploy it into a C environment. This will save you a ton of time, believe me. And if done right, it's just an awesome way to do it. On top of you got this amazing simulation environment to play with as well. Over and out. Talk to you later.